I designed the flow chart intentionally because I wanted you to have, I'm going to pull this down for a second. Catch any second now. There it is. So if you're on the resource page, this little flow chart that was back here, a couple sections back, I might have made a couple of you a little bit nauseous last class. I hope it didn't. That wasn't my intent. But if you're estimating a parameter, which is what we're doing, which one, mu, how many? There's two. Put the mouse right on top of the two. So if you zoom in on that one right there, whew, there it is right there. So it's waiting for you there if you need it. It's waiting for you there if you need it. Okay. Not that you ever have to memorize a formula. Right. Because the formulas for these things are hellacious. Absolutely hellacious. The margin of error for this monstrosity it's not worth doing. It really is not worth ever doing manually. So I've got it all programmed into Excel. The kicker is what do you do with your data? That's the important thing. And the really important thing is making sure you know what Shannon just gave us, which is the form that we need to do. I'll give you an example. I had a 243 student 2 days ago she's doing a, not an apprenticeship, but whatever that's called when you're in the field working, like you're working on your bachelor's degree and you're out in the field.
Internship?
Internship, thank you, not an apprenticeship.
Externship?
Whatever, extern, intern, whatever it is. And she had a bunch of stream flow data and she brought in, and she's needed to talk about a normal stream flow based on these data points. And she's like, and I did what you told me. I kind of graphed them, and I looked at the graph, and I'm like, holy crap, it does this. And she's like, and I took an average, and I'm like, and what'd you think? She's like, that seems wrong. So in other words, all this stuff didn't fit her data. And that happens. That happens. Sometimes you catch stuff in life that doesn't fit the checkboxes of these. This is the curriculum of this course. So the important thing is then being able to go online and look, okay, here's the type of data I have. And eventually you'll get to a point where it describes the form of the interval you have to build. And then you just build it from there. We needed something called median absolute deviation. Never heard of it before. Totally wonderful. Brand new. Super fun. And then we built a conference interval. She's like, oh, that seems like magic. I'm like, yeah, it's not magic, it's Google. And that's it. But the important thing is knowing what the form of it is. It's always going to be statistic minus mo, statistic plus mo. All you've got to do is feed the statistics in and get those numbers out, and then you know what you're confident in. Is that fair? Hopefully, maybe. Let's do it. Let's do it. So, grab your Excel calculator. We're not going to use single mean confidence interval. I don't want to lose confidence. We're going to use two independent mean confidence interval. Yes! It's 1 over. I guess I put them in non-alphabetical order. Okay. All we got to do is feed our data into this monstrosity. I set it up the same way. I set it up in the same way such that you could just copy and paste from the other spreadsheet if you're in the middle of doing it. Now we've already done the crunching, so we're done. We're going to put them in from here. But in general, you'll be flipping back and forth from the other sheet to this one. You'll be crunching the numbers in one sheet, dropping them into this one, crunching, dropping. But we did that earlier. So all we got to do is come up in here. Now I'm going to zoom in a little bit. Whoops. Now, the one thing I want to caution you against, and this is a math caution, and it's only a math caution, it's not anything else other than a math caution. I put experimental group first and control group second. Generally speaking, it doesn't matter, but since it's subtraction, and subtraction misbehaves if you switch the numbers, you want to know which number you're subtracting from what. Does that make sense? So I listed these, cantilever and then V. If we're calling the V breaks the experimental group, we should put these numbers in first. Does that make sense?
That's what I did.
That's totally fine. I also wouldn't mind doing them the other way so you see what happens to the numbers. But it freaks some students out when they start seeing negative signs, and I don't want to freak anybody out. So let's do it. Let's put the cantilevers in first. So experimental group's going to be, whatever the hell that was, 16.4.
But this way shows the true data.
When you say true data, what do you mean, Paul?
Your experimental group your experimental group minus the control group.
So when you say true data though, what do you mean?
What is the difference from the two?
Right, but the
Instead of
thing,
using a positive number, you'll actually come up with a negative number that'll show you a downturn from your experiment.
okay, so hold that thought, please, if you would. I want to get back to that. I want to get back to that in a second. I promise. So all you have to do is fill in those 6 boxes. That's all you got to do. Excel takes care of the rest of the calculations intentionally. Did you see it? Watch everything updating as it was going. Now Paul made a statement. He said, if you do experimental minus control, you see negative values. Now this might freak you out a little bit. But why are negative values okay? Right, remember, cantilever is working worse than V. That means V takes less distance to stop than cantilever. So this number should be smaller on average than this one. And if you do smaller minus bigger, it should be negative. That was a lot of commas, but did that train of... Fair enough? Fair enough, I hope.
Yeah.
So, if we put the experimental group as the V-brakes and the cantilever groups as the control group, I get an average difference of negative 6.6, which is just these two guys subtracted from each other. That should be fairly straight. I hope that's straightforward, just one minus the other. But don't forget the margin. If you're interested, and I encourage you to be interested if you want to, you can click in these cells to see the actual. Actually, these are easy. You click in these cells to see the calculations. They're pretty heinous. I'm not going to lie to you. The margins of error on these things are ridiculous. Coding it into Excel took a long, long time. But the margin of error is about 1 foot, plus or minus 1 foot. So you take that plus or minus 1 foot and you add and subtract it to negative 6.6. LCL, negative 7.6 feet. UCL, negative 5.6 feet. Let's go over here. Oh, you're good. I won't need that here. Intentionally, anyway. What should I call this axis? What should I call this? If I want to draw this confidence. I didn't draw a confidence interval in Excel this time because I couldn't get the damn negative numbers to work right. So I just said, hell, we'll draw in class. What should I call that horizontal axis? What should I title it?
Feet.
May I get a little more specific?
Units of feet?
No, it's going to be in feet. The units are feet. Let me actually, Paul, you're 100% right. These are all in feet.
Stopping distance.
Difference of braking distance?
Can I put both of those together? Difference in stopping distance. Because that's what I'm going to be graphing, aren't I? I'm not literally going to be graphing the actual stopping distances of the brakes. I'm graphing the difference of the stopping distance. Does that make sense? Hopefully that makes sense. So I'm actually going to be graphing the differences in stopping distances. And I'm going to put a little note on here for my readers. V-brake versus cantilever.
There you go.
I just realized it. Could you spin that camera? That's completely useless pointing toward the front. I told the administration at COCC we need to hire a perfect
Cameraman?
Yeah, I know. We need to hire. We need a group of an administrative group on campus that actually does this well, not ghetto like I'm doing. And we need somebody to actually record classes, edit them, put captions on them for hearing impaired. So we don't have any money. Told them they built a dorm. They didn't like that answer. So anyway, back to my ghetto films. So anyway, it's not Jack Body film. I'll hire you instead. So differences. Let's put the interval up there. Let's put the interval on the line. Negative 7.6 to positive, to negative 5.6. Negative 7.6 is right around here to negative 5.6, which is right around here. There they are right there. Is this statistically significant evidence, number one, that the V-brakes are doing better than the cantilevers? Give me a yes or no for starters. Is it statistically significant evidence that the V brakes are doing better than the cantilevers? I'm going to swing this in a little bit more. I'm going to zoom in.
Yes.
I hear a confident yes. I hear a not so confident no.